So today we want to start talking about HTML injection attacks. This is one of the most important security aspects we'll talk about in the course. There's security sprinkled out throughout. We've already talked about a couple of security issues. We talked about SQL injections, where your users will try to submit SQL queries as part of their form submissions to be able to get you to try to get you to run their SQL statements on your database, which is very scary. If you're susceptible to that, an attacker, even a pretty unsophisticated attacker, can take down your whole system and potentially steal all of your users' private data, which, of course, I hope we all agree is a very bad thing. So we don't like that. We also saw content type. Blanking on the name of the attack. I don't think I named it in lecture. I don't know if I ever knew. But taking advantage of content type sniffing. So if you ask for a file to be uploaded, an image to be uploaded, and some user says, well, I'm going to submit JavaScript instead. They submit JavaScript, and then you host that image, which is actually JavaScript, to all of your users, and you say, hey, browser, if I get the wrong MIME type, help me out. Be a bro. Like, figure out the MIME type for me. And the browser says, that's JavaScript. I'm going to run it as JavaScript. That's bad. So we always disable the MIME type sniffing for the browser. So if we say this is an image and it's not an image, don't run anything. Don't attack all of our users. That'd be a very bad thing. Yeah.
So if some kind of malicious JavaScript file gets sent to the browser just takes it, runs it, whatever happens.
Yeah. Yeah, I mean, if it's in a script tag. So that attack is a little tougher, that I just mentioned. It's a little tougher to pull off because the image should be in the source of an image tag. So, it won't automatically run it in a lot of cases. But if it's in a script tag, like if you put script source equals my JavaScript file, that runs as soon as it downloads. It immediately runs that JavaScript. Now, if that JavaScript is a library, running it just defines all the functions in the library. But if there's any code, like if it's a script, which if I'm attacking a website, not that I would, I'm going to write a script, not a whole bunch of a library of functions. And that's going to run as soon as the browser gets a hold of it, puts it in a script tag. So you got to trick it enough to say, hey, run this right away. But it's something we need to worry about. So we disable the content type sniffing to say, look, I said it's an image. If anything goes wrong, just don't do anything, browser. Please, don't do anything. If it's not actually an image, something else messed up, don't open up this attack. The other one, which comes up right from Objective 1, is escaping HTML. This is something we haven't talked about, and this is what we want to talk about today. So security issues are critically important. We've all seen headlines where companies leak data, where they have security breaches and stuff. It's never a good thing. People get fired. You can lose your job just for forgetting to do something like this. Your company will be making the news for all the wrong reasons. So if you have any security issues, it's an auto 0 for that task. So any security issues, make sure you're plugging up your security holes. It's much, much better to release a really crappy app that's secure than releasing the world's greatest app with all the best features and everybody loves it. It's got an amazing user interface, but it's insecure and it leaks user data. Your credit card's going to be out there if you use this site. That's a trash site. That's horrible. That shouldn't exist. It's so bad that it might as well not exist. It's doing more damage than good, even if you built the best app in the world. Much, much better to have a crappy app with a terrible user interface, a terrible user experience that doesn't leak private information. So, and my grading policy reflects that. Yeah.
Can we assume that we are just passing the JPEG or?
Yeah, so for the homework, let me make sure I mention this explicitly. Right here. It's okay to just assume that every image is a JPEG, and if somebody uploads a PNG, if you just don't handle that, that's fine. So always set, and the reason for that, just always set your content type to image/JPEG, and then disable content type sniffing.
Do you need to send any kind of response like report not found or bad request, something like that, or just reload the page in that way?
Sorry, what was that?
So if someone uploads, for example, a PNG file and we don't support it, should we say bad request or should we just reload that?
Just reload. So if somebody submits a PNG or anything that's not a JPEG, since you can assume that it's a JPEG, I don't care what you do. You can do whatever you want for it. What I would expect, since you don't have to handle it, is that you would save the PNG or JavaScript or anything as a JPEG image. It would be completely corrupt. It wouldn't be a working file because all the bits are not encoded with the JPEG encoding. So it won't work at all. And then just serve that to other users, and they'll get the broken image link, and that's fine. For testing, we'll only throw JPEGs at you. And then for the security issue, we're just going to look at the headers and make sure MIME type was disabled. The MIME type sniffing was disabled. And then maybe the MIME type, but if the image shows up and sniffing was disabled, then we know that you have the right MIME type. Yeah?
How could a crappy website steal a credit card?
How could a crappy website steal a credit card? Like an attack site, like if you click on a shady link? Is that what you mean?
Yeah, like how does that work?
We will talk about this a bit throughout the semester. There are certain attacks we'll talk about. The short answer is hopefully they can't. If you're doing everything securely on your website, the shady links can't attack your users. But if you slip up with one thing, that can open the door for those attack sites to steal your users' information. Or if you're using a site where the developers weren't completely careful about security, then your information can be stolen with those shady links. Is one way. And it depends on your operating system. If you're on Windows, they can try to download things with auto installers and things like that. If you click, if you're downloading stuff, that's a whole different thing. But with just injecting JavaScript, the big thing is if you're not securing your cookies properly. So with our cookies, when we have secure cookies, we're going to disable third-party sites from accessing our cookies. And then that really limits what the attackers can do in that regard, at least.
So it's less of having an online store that stores all their credit card info plain text, but it's more like somebody submits JavaScript code that a user would have haphazardly downloaded.
It can be both. So there are a lot of, and security on the web is a huge topic. So there's a lot of attack vectors that can be taken. So you're talking about two different things. The first one you mentioned was a user trying to attack the database of the server. That would be our SQL injection attacks and buffer overflow attacks, things like that. And the second one you mentioned was attacking the user's private information that they have direct access to. I worded that weird, but you have private information in your cookies. For example, we'll talk about this for homework 4. Every site where you're logged in, you have a cookie that stores your authentication token. And if somebody steals that cookie, that value, they can just log in as you on that site. That's the only piece of information they need. They don't even need your password. They just need that token that's stored in a cookie on your device. So if they can steal that cookie, which if that cookie's not appropriately secured, they can steal that cookie with JavaScript, and that's where clicking a shady link could leak that information. We're going to learn how to safely protect our users' cookies so it won't happen to us, won't happen to anyone in this room, I hope, if you remember to do these things. But if you're using a site that's not put together very well and didn't pay attention to security stuff, those cookies for those sites could be vulnerable and then might be stolen by shady links. But the shady link has to attack like a specific site, a specific app that you use. H1 high coal, high latitude. All right, so let's talk about our, I guess, third attack vector that we're talking about in this class. Is there one I'm forgetting? There's got to be one I'm forgetting, because the lecture question lists 4 of them. What one am I missing? So let's talk about HTML injection attacks and talk about what this is. So for homework 1, we didn't have to worry about HTML injection, because the way our site was built, it was just hosting static content. Static content is content that doesn't change. No matter what, no matter how many users you have, no matter what they're doing to use your app, your homework 1 server was always serving the same content. That's not true with Objectives 4 and 5, is it? But your users had very limited control over the data in your app. I guess they did in Objectives 4 and 5. Let's ignore that for now. That was JSON, not HTML, so this vector doesn't apply, but kind of ruins the sentence I was just spilling up. For Objectives 1 through 3, it was all static content. The users have no control over the content that's served. Homework 2, that will not be the case. Your users are submitting text and images to your server, and those texts and images, that text and those images, will be served to all of your users. So if somebody gets an attack in that information that they're submitting, you're storing that attack in your database and then serving it to everybody who visits your page. So the level of care we have to take for security issues skyrockets once that's the case. Once users are submitting information that's viewed by other users, which is a feature we want in our web apps. Like, we're not just going to not do that. Like, well, I won't open myself up because I just want a lot. We want apps where users interact with other users. So we have to have user-supplied data served to other users. So we have to think about the security concerns of this. One solution is just, I trust my users. No, you don't. Never trust your users. I cannot say this enough. Alan, you take his 370, he'll say this, 365, he'll say this enough. He probably says it in 370 as well. Matt Hertz says this in 442. I'm going to say it in 312. Never, ever, ever trust your users. That is not valid security to just say that my users would never do that. No. They'll do that. They will. They will. So you must protect against them. Never trust your users. That is not security. Seriously, never, ever, ever trust your users. They are out to attack you. They are the worst, most vile people, and they will attack any security vulnerability that you possibly have. And you might say, come on, it's my users. They're the best. They're the reason I'm in business. They're my users. I trust them. Sure, but your app's available on the internet, which means everyone can access it. It's not just your trusted users, because you might actually trust your users, and that's fine, at least to some degree. But it's not just your users who are using your app in good faith for the purpose of that app existing. It's not just them using your app. It's literally everyone who can access your app. So you might have users in your database, they created accounts and everything, who are not there for the intention of using your app. They're not actually your app's target market. They're just attackers trying to attack things. So don't just trust your users, because they're not all your legitimate users. So when we say don't trust your users, this is what we mean. It's, do you trust... Oh, did I not update this? I think I forgot to push. I added one slide there that, do you trust literally everyone? That's who you have to trust if you're trusting your users. Literally every person, somewhat on the planet, but at least with an internet connection. Do you trust every single person with an internet connection? I hope you say no. If you say yes to that, I have some news for you. You're a little too naive. You can't trust literally everyone. Somebody out there is attacking. And I think we got time for stories, right? There are, and these aren't always like attackers looking to attack your site either. So in 115, way back, years and years, probably 5 or 6 years ago, For 115, I hosted, it was a self-hosted Q&A site. I didn't really like Piazza. I'm using Piazza now, but at the time I was like, there's got to be something better out there. So I self-hosted an app that I found, an open source app that I found online. And it was a nice Q&A with kind of a setup like Stack Overflow. You'd ask a question, get answers, and upvote and downvote and all that good stuff. And it worked well. I actually did like it, the feature set more than Piazza. But I noticed, I said, hey, class, this is what we use, blah, blah, blah. And they started signing up. And it was a class of like, I don't know, 300-400 students or something. And I was watching the enrollments, and I said, oh, hey, I got like 200 users after announcing in class. That's cool. A lot of them are going to be using this site. And they started posting questions and stuff. And then I checked like a week later, and I was like, I got 2,000 users. Holy crap, even people outside of the class are using this thing. This is great. This is like the next big thing. They loved it so much that they spread the word and everything. And then all of a sudden it got up to like hundreds of thousands of users. I'm like, okay. I'm speaking of naive, I'm not that naive. These are not people interested in education. What it was SEO. After investigating, I found this out and talking to other people about it. It was SEO firms, search engine optimization, who were creating, using bots to scan the internet, just any IP address, looking for apps that they could create accounts on and then try to make posts to improve the SEO of their clients. So I looked through the email addresses for these, and they were all just clearly randomly generated email addresses. They were all fake. Luckily, I had email verification enabled, so none of them were actually able to do anything. Only actual students in the class were using the app. So the students never saw any of this, except I talked about it in lecture. But they were creating accounts like multiple times per second. I was getting accounts created, just huge numbers of these things. And I'm like, why are they attacking my Q&A site for 115? The answer is they're not. They're not. They have bots that are scanning every IP address. Like they probably have bots that know this specific vulnerability of this software, this open source software that I found, and they have bots specifically targeting that software. That's what I assume. I assume that's the case. And they just scan every IP address and look for an installation of this thing, and then if they find it, their bots just go to town, and no human was probably ever involved in the whole thing. They just have these bots that scan everything, except the human that wrote the code originally. But don't think, oh, my app, it's got a couple of users, it's so small, nobody's going to target me. They don't have to explicitly target you. They're just scanning everything. If they're scanning and find, oh, you got a SQL injection vulnerability, they might find that. They might find it. Yeah?
Isn't this illegal?
It's at best a gray area. I doubt it's actually illegal. Shady as hell, but I don't know about illegal. Plus, they're probably, if I were to guess, probably not operating in the United States. So illegal in their country, almost certainly not. Illegal in the United States, maybe if you have a really good lawyer to fight it, maybe they'll find it illegal. But and usually, so these companies do shady things, but usually they're customers that say, hey, I'll give you X dollars, pump up my ratings, make me hit number 1 on Google for these specific search terms. The companies paying them usually don't know that shady stuff is going on, and then these companies just do shady stuff. But hey, if your search results go up, who's asking questions, right? It's kind of messed up how it all works, but it is what it is. Google created this huge game. SEO is a huge industry now. And those are the kinds of things that I got to witness them doing. It's kind of neat to see it firsthand. Yeah.
How did you end up fixing the issue with this
How did I fix the issue? I added a CAPTCHA to it. The software that I was using, it was literally just a checkbox. I checked that. It added a CAPTCHA to enrollment, and then it completely stopped. Which I was sad about because then my legit students had to do a CAPTCHA to use the site, but it is what it is. And they weren't able to make posts, but I had to talk to someone to figure this one out, why they were still doing this. They couldn't make posts, but their profiles were public. So their profiles would all have links to the pages that they were promoting, and that would boost their Google score because Google would eventually find their profiles and say, "Whoa, that site just got 100 new links today. Let's bump them up." Was their end goal. That was their game. It is pretty pretty neat. I did have a strange appreciation for what they were doing, but I had to shut it off. I can't be involved in that. So don't trust your users, because some of them are just bots. I mean, we hear that a lot in social commentary and stuff, but they actually are out there. They're bots scanning everything, not just making social media posts and stuff. They're out there just looking for vulnerabilities. Never trust your users. So what does this mean to us? What's the vulnerability that we're now open up to on homework 2 that we weren't open up to on homework 1? Well, somebody can inject HTML into your page. So in your form takes text, and you hope that they say, "This is an image of an elephant. Ain't that neat? Look at its trunk." You hope that's what their captions are going to say. But what if some attacker says, "This is my caption for my image. Script tags, whatever JavaScript I want to run, script close tag." And you just throw that in your HTML. You have your HTML template where you're taking the string from the database and jamming it right into your HTML and then serving that HTML to your clients, to your users. And now your HTML that your server is serving has malicious code injected into it. This is an HTML injection attack. A user is able to get HTML that they wrote, which HTML isn't, uber dangerous or not crazy, but HTML includes script tags, and then they can write any JavaScript they want. So once they inject the JavaScript through their HTML injection attack, they have whatever JavaScript that they want to run running on every one of your users' machines. This is bad. Oh, I got ahead of my slide again. I gotta stop doing that. So the user submits this, you store it in your database. Every user who visits your page, you retrieve it from the database, jam it in their HTML, and then serve it to your users. You're serving attack code to every, not code, HTML, well, code, because it's JavaScript in this example, to every single one of your users. Yeah.
So the string that gets uploaded is a whole Python function? Or
JavaScript, yeah. It's whatever, so you have a text box on your page that says caption for this image or whatever it says for homework 2. And they type this, and then, I don't have the function defined here, but whatever JavaScript code they want to write, they just type all of that in that text box and click submit. That's the danger. Luckily, the prevention for this is super easy. We need to escape 3 different characters. Ampersand, less than, greater than. If you're not allowed to use any of these 3 characters, just try writing any valid HTML, much less a script tag, to be able to get some JavaScript. So super easy to prevent. So we're going to escape these 3 characters into their HTML escaped equivalents, which we saw way back, weeks ago. But there's a reason I mentioned it then, so I could talk about it now. Ampersand, the HTML escaped is ampersand amp semicolon, ampersand LT semicolon, ampersand GT semicolon. So these are the named escape strings. You could also look up their ASCII values and that, but we have named constants for certain characters that we want to escape all the time. We want to escape these all the time. These are the most 3 common that you'll want to escape. So we have named constants. HTML has named constants for these ones, amp, LT, and GT. So we're going to replace, whenever we get user-supplied information, we're going to find and replace these 3 characters with their escaped counterparts, and then they can't inject anything. When the browser sees ampersand GT semicolon, it'll replace that with the greater than sign and treat that strictly as a character, not as part of an HTML tag. It will not parse that. It'll treat it strictly as that character. These are named constants, but you could put the UTF-8 values instead. But so we don't have to look, because as developers, we escape these three all the time. Instead of constantly looking up the UTF-8 values for these three characters, the HTML developer said, let's name them, because I can remember amp, LT, and GT. LT less than, GT greater than, amp, ampersand. Like, I can remember these. I have these memorized. I had these memorized for a long time. I have no idea what the ASCII UTF-8 values are for these. Yeah. AMP?
AMP ampersand.
No, it's ampersand. You've been spelling it wrong. Sorry, I don't know how to break this to you. Your life has changed today. You had me question for a brief moment. I'm like, is it ampersand? No, ampersand. And then your browsers will just render these symbols and not treat them as HTML when they're escaped. So now this script becomes this. It's no longer rendered as HTML. We can't get to the JavaScript. The JavaScript is just going to display as general code, and nothing happens. This, for what it's worth, this is something you should think about too, or something you have to think about if you want to have, say, a mathematical formula in your actual content of your HTML, and you want to say like x greater than y or something like that. That's going to display as part of an HTML tag, so you have to escape that greater than when you have that code as well. So it's something we have to think about outside of security as well. And the order is important here. More of a practical note, but I had this question often enough in office hours that I devoted a slide to it. Make sure you're escaping them with the ampersand first. I'm reading my slide. I'm like, why do I say ampersand last? Ampersand has to be first. Make sure you escape the ampersand first, because the escaped less than and greater than sign, the escaped versions have ampersands in them. So you don't want to escape the ampersands, which are part of your escaped characters. So just a note about that. So if I have ampersand LT because I escaped my less than, and then I escape ampersand after that, I'm going to get the escaped ampersand and then the LT semicolon, and things aren't going to render right. You're not going to see what you expect to see. In the browser, everything's kind of janky. You're seeing partial escaped characters. If you see weird behavior like that, make sure you double check your order. Replace the ampersand first, and then the less than and greater than. And for what it's worth, with just these three, you'll be covered with this. If you want to go beyond, some libraries will also escape single and double quotes. So you can go a step further if you want. As long as you have these three escaped, though, you're definitely good on the homework. And I don't know why some libraries do that. I've never seen or heard of an attack where if you can use quotes but not these three characters, you can get in. But I have seen it. Yeah.
Do we have to do this manually, or are we allowed to use like functions for this?
Manually on your homework, functions for your project. But if you look at the functions you're calling, go into the code of those functions, they literally just replace these three characters and sometimes single and double quotes. Yeah.
If you add the short script like or ampersand or anything, like if that was what you wanted to submit validly, you were trying to submit code, you still get the same rendering error.
Yeah. So even if these three characters show up legitimately in your code, you'll want to escape them so they'll actually render as part of content.
When you or like with the ampersand, if you're replacing that, it's like if you already had.
Oh, yeah. Right. Yeah, you have to be careful with the ampersands for this reason. You don't want to make sure you don't escape it twice. So if you're like, well, for extra security, I'm just going to escape it in like 3 different spots just to make sure it's escaped. Well, your ampersands just got really jacked up. Yeah.
Are there issues related to spaces as well? Do we need to escape the spaces?
Yeah, you can escape spaces. It's NBSP, non-breaking space.
And can you use some kind of library, like input Python library to parse the URL, parse it as well?
a library to parse URLs.
Yeah, so if you have the image name and if you want to parse everything instead of replacing, you just use some library.
I'm going to say no on that one, because I did talk about that, and it's part of your homework to create those names. I don't know how much that would save you, though, either. Because you just look for the slash, and then everything after the slash. That wouldn't save you much, because you're going to go through a lot of parsing with the multi-part form parsing. That wouldn't really, that would get you like 2% of the way there. So it wouldn't make that big of a difference anyway. That's more of like a warm-up for the multi-part. And demos. Okay. I panicked for a second there. I'm like, what is on my screen? I always have to be careful in this code base because I don't want to leak too much code. And I thought that was code I didn't want to leak on the screen. It's fine. It's not. But let's do this. So I have my app running already, so you don't have to watch Docker startup. Then I'll restart it when we make changes here. But I have a path for what I call insecure chat. And whenever I get a post request for this form, I'm going to handle it, I'm going to handle it like this. This is exactly the code I wanted up. So I'm calling a lot of functions and methods and using classes and stuff. I strongly recommend you do the same. Some of you just won't, no matter how many times I talk about it. So whatever, you do you. But I do recommend this. So when you do see code like this, like parse multi-part, request.parts, append is Python, escape HTML, redirect, and handler, I guess, dot request, this part of it, and this request and handler stuff. All this stuff is code that I've written, which is defined in other classes, other files. Some of them are classes, like I have a request class, which is doing my header parsing and things like that. And then I have those defined in other files here. So don't look at this and say, oh, Jesse's using libraries in his example code, but he said we can't. No, I'm not. I technically am, but I wrote those libraries. I recommend you do the same, because this is how you can add a new path to your code. Nice and clean. I have a route class, and then I create an instance of that class to create a new route. And I can separate and encapsulate things to my heart's content. So I don't have any mess of code. I have a small amount of code that I'm going to look at. So this is going to store in my chat history, and then that chat history we saw last time is going to be rendered using an HTML template to be rendered to the screen. Let me resize this a little bit. Get rid of this. Don't need you anymore. And this is my page. And we're talking about this form right here. I might as well show the inspect element. Might as well show the HTML since we talked about it a bit, and we'll want to be in here anyway. So this is the form, which is going to send a post request to insecure chat as multi-part form data. And it's going to have two things, a username and, oh, I forgot to change this. I'll hack the HTML directly here. Message, which you can do, by the way. There's a lecture on that next week. I'll talk about it in more depth. But you can change the HTML of any page you visit. Knock yourself out. It's fun. And I'm going to submit to this. Jesse, hello, post. And I should see my message there. Oh, why do I have two of them? I thought I deleted this. Did I not restart? I might not have restarted the server. Hartloff. Hi. And my messages show up. So what if I get a little, I have some right here. What if I get a little creative with this? I like horizontal rules. I don't know. Oh, I know why it's showing up like that. I know why. And I could add one. It's because I already attacked it. This is my attack from earlier. And I can start adding HTML. If I want my username to be super big, And, oh, it's already here. I'll type it anyway, but I've done this before. You've been hacked. I can run any JavaScript that I want. Let me make sure my syntax is right. Alert. I'll even add my semicolon script. I can add any JavaScript I want because I'm going to add my HTML script tags. Bam, I've been hacked. I can run any JavaScript that I want to run, and that's going to run on anyone's machine who visits this site. It's going to run on everybody's. So I've just been hacked. My name's big. I have a lot of power here, and my favorite one to add is this one. If you just want to break things and you're not worried about stealing information, I'm just going to add an open comment. And now everything after that, I'm not going to be able to see because it's all commented out. So I just opened the comment, but I never closed it. And then if I want to, I could close it. I've been hacked, though, every time. And then I can change the content there. So I can see all the content. This commented out, and then eventually I commented back in, and then the rest of the messages. But I have a lot of control here. And I'm not just breaking my HTML. Like, the first thing I did is I changed the HTML, like my copy of it on my machine. That's pretty harmless. You can do that with any page you visit right now. It's harmless. But I'm submitting this for every single user. I go to another tab, and I say, oh, I'm a different user now. I want to go visit this site, and oh, crap, I've been hacked. I didn't even do anything. I just been hacked immediately because my server is hosting the hacker's code. That's bad. So to fix this, I'm just going to escape ampersands, less thans, and greater thans. Don't overthink it. This is all your method needs to be. I'm showing it in code. I'm showing it in lecture. Any code I show in lecture is always fair game. Like, that's all it is. Let's see. And just to, actually, since I mentioned it, import HTML, HTML.escape. So this is the built-in Python library that you would use. But if we look at the code for that, it's the same thing. It's replaced 3 times with an option to replace quotes. It's not by default. Oh, it is by default. But you can turn off escaping quotes. I don't know why, but I'm sure there's a great reason. But that's all it is. It's nothing complex. We don't need to overthink this. But to prevent HTML attacks, that's it. Escape those 3 characters. Make sure you do ampersands first, then return it. The hardest thing about protecting against HTML injection, the hardest thing is just remembering to do that. You just got to remember. And I don't mean to understate that. It's hard because it's something you always have to remember. Whenever you're handling text that's supplied from a user, you have to just remember to do it. As long as you remember to do it, you're fine. And unfortunately, I do see there's always a handful of teams, like multiple entire teams in this course, who forget to escape their HTML in their group project. And that takes a significant hit on their grade. Depending on where exactly, I usually give zeros for each feature that's affected. So if it's in their chat, like that's a 0 for their chat feature, or whatever the feature breakdown is. They get poor grades. For an entire team of students to forget to do it is a bit more egregious, but you just got to remember to do it. So let's do this again. Let's hack again. Since that's escaped, it just shows up as text. If we take a look at the HTML, if we take a look at the network tab, refresh the page, go to response, and look at the actual HTML that was served, we'll see our escaped characters there. So this is what we actually got from the server. We got those escaped characters. The browser sees these characters and replaces them with the characters that were escaped. So we see the actual text in the browser, but what was actually served were the escaped characters for those less thans, greater thans, and ampersands. I guess I don't have any ampersands here, but ampersands as well. We can see my redirect too, I guess, since we're here. Any questions on this? Everyone's going to remember to do this for your entire careers too. This is so important. This is like the easy, like you forget that one thing. You just forget to escape your HTML and you go live. You're working for a company and all right, we're ready to go live to our users and you have that vulnerability. It's bad news. Like things are going to break probably within minutes of going live. You'll see this in a lot of new apps like that. Like whenever, I won't even be talking about HTML injection, but if I put an app live to a class, any class of CSE students, one of the first messages is going to be script, alert, or button, redirect to my page or whatever. It'll be someone testing me to make sure that I escaped HTML. Users will do that when you deploy apps as well. They're looking for this. Enough people know to look for this that it'll be one of the very first things that they do in pretty much any app. Yeah.
Is 302 redirect an okay message for like refreshing the page after receiving a response?
Yeah. So I'm redirecting to my home page. So I'm saying, where's my location? Response headers, location /. So instead of loading form path or whatever I named it, I want to redirect them back to the home page. This is as opposed to at the path form path, returning the home page. Gets messy, gets hard to maintain. So we're going to just redirect them to the home page. By the end of this, by homework 3, we're not going to have to worry about that because we're going to be using WebSockets. But for now, we're going to redirect. Yeah.
So there are bots just circling the internet,
Oh,
going
yeah.
to random websites and trying to put HTML in the responses.
Yeah, and they're pretty sophisticated, I assume at least, because, I mean, they got me. But they're just scanning everything. And if you're scanning, like, all IPv4 addresses, I mean, there's billions of them, but that's not that large of a number. You could hit every IP address without, without...
Stop that?
Who? Oh. No. No, because that attack wouldn't touch a browser. It's their software, which wouldn't be using a browser, sending requests to your server. So it's up to us to code our servers to protect against that stuff. Like we made requests using Postman. That, strictly speaking, didn't come from a browser, even though we're using the browser Postman client. Like Postman got to formulate whatever requests they want. You could write Python code to send a request in any format you want, with any headers. Like you're sending your responses, you could do the same thing. With what we know right now, create a TCP client and just send whatever bytes you want and form your HTTP requests in whatever format you want. You do not have to go through a browser. And those attackers, like, almost certainly are not using browsers. One last thing I want to talk about, since we're in this code, and I have to be very careful, as I mentioned. This should be where I want it to be. Okay. Is testing. Yes, have you heard that since 116? Testing. No required testing for this course, but my goodness, I strongly recommend doing at least some level of testing. Doing my solutions to assignments to the homeworks for this course, I wrote tests because they save me time, not because somebody made me do it or because it's a good idea or, well, I teach it in 116, I don't want to be a hypocrite. Like, they helped me. They saved me a ton of time. So this is one of the test cases I wrote for, a partial test case anyway. I wrote for my parsing HTTP requests code. So I have this request class. The constructor takes a byte string, and then I expect a whole bunch of values to be in this request after it's created. So what I did was I went to my ran my app. I ran it to just print out each request, the bytes of each request. Went to my browser, sent a request, copy and pasted those bytes. I got a whole request. It's a GET request. It ends in /r/n/r/n. And then I can call my code and then assert. And Python has assert built right in. So you can build test cases in a main method. You don't have to import a library. You can if you want to get formal with it like we did in 1.16. Or you can just assert the things that you expect, run it, and if everything's fine, it runs fine. And then I can actually assert something that I know I got wrong. The host should be localhost :8000. Let me run this. And I'll get an assertion error. Host did not equal 8000. And if I look at this, which I didn't actually do the asserts, I'll admit. I didn't do the asserts when I tested this. But what I did was run this in the debugger. And you can do this without running your server. If you have main methods in your classes, you don't even have to run your server to test your code. If you're running your server every time you want to test a line of code you've written, you're wasting a lot of time, especially if you're doing it through Docker. But for each piece of functionality, write separate methods, call those methods, test them, and test each one separately so you can make sure that all of your pieces are good to go. And then you're only running your server to test the integration of all those pieces, the integration testing. So instead of the asserts, I like to run the debugger. I'll open up my request. I'll make sure all the values are what I expect. For a small application like this, of course I'd run unit tests if I were building this out to be a legit app. And I can see my host is localhost instead of localhost 8000. And then I can look through my code and say, oh crap, I'm splitting on colons. I'm taking this header, splitting it on colons, taking the first value as the name and the second value as the value. Well, I lost this 8000 because it's after another colon. So that's a bug I can find by writing my unit tests that is going to be pretty hard to find otherwise. If you're using that host value and expecting it to be something specific, it's going to be a tough one to find. But here, I can look through all my headers. Are all my headers exactly what I expect them to be? If they are, I'm feeling good about it. Strongly recommended. Strongly recommend that you write your unit tests and test each piece of functionality separately. If you're in a giant if, else if, and not even calling helper functions, it's going to be tough to do, and I recommend you do something else and write some helper functions and test those functions. Yeah?
So wasn't that the beginning, like if requests don't actually have a RN at the end for some reason?
They do. They will. If you don't see that, if you don't see this, make sure you're not calling .strip. The documentation for Python TCP servers has a .strip right at the end of the receive call. If that's there, you're intentionally stripping it out. That's the first thing I would look for. Because whenever I've seen that with students, that's what was the issue.
Should we not use .strip then?
No. Mm-mm.
Is that like
Is there a reason you want to use it? Is there a reason you want to use it? The only reason it's there is because, let me switch this over actually. The only reason that .strip is there in your code is because it existed in the documentation. You didn't decide to put it there. There's no advantage to having it there. Yeah.
So on off topic, I didn't mean to make this back, but would you show how to get this working with the documentation so you can see
How?
the
No, yeah, I know. Not today in lecture. If you mentioned that earlier, I might have had time to mess around. I honestly don't even think I have it installed on this machine. That was on my other laptop we were saying. But yeah, thanks for the reminder. I do want to show that at some point when I have a lecture with time. Oh, that was the other. I was trying to think of what the fourth attack was. Yeah, don't click scam emails, folks. And have a great weekend. I'll see you all on Monday.